Today we are doing lesson 6.5% of increase and decrease. Our I can statements, I can find percent of increase and decrease. So our key idea for today, here are the formulas that we're using, and actually it's pretty much the same formula. Percent increase is when the amount of the original increases, and then that's called a percent of increase. And we find a percent of increase by taking our new amount and our original amount and subtracting them so we get a positive number. So our new amount is going to be bigger. It comes first. We subtract. And then we divide by the original. Percent of increase is sometimes you see on like food packaging, like now 50% more chips or cereal or whatever it is. New, bigger bottle, that sort of thing. That is a percent increase. The percent of decrease is the opposite, that it's getting smaller. 20% less sugar, something like that, or something is getting smaller. That's going to be a percent of decrease. We still subtract our numbers in a way that gives us a positive answer. This time our original comes first, but really it's whatever number is bigger. That's one that's going to come first when we do these problems. And then we divide by the original. So we subtract our numbers, make sure our answer is positive, divide by the original, and then we make it a percent. That's the steps that we're going to be using today. All right, so let's start with this situation. It says the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Okay, so over here are the two numbers we're using, 2 and 4.5. We need to subtract in a way that's going to give us a positive answer, which means the 4.5 comes first. 4.5 minus 2 is going to give us a positive answer. And then we divide by the original. That means what number happened first. In terms of days of the week, Saturday comes before Sunday in a weekend. So we're going to be dividing by 2. That's the first number that occurred. All right, 4.5 minus 2. Now with the decimals, you might be able to do it in your head, but if not, you can always line them up off to the side, add a placeholder 0 here. 5 minus 0 is 5. 4 minus 2 is 2. So subtracting those two values gives us 2.5 divided by 2. All right, so now we're going to actually do our division. So 2.5 divided by 2. Yes, you are allowed to use a calculator to help you if you would like on these problems. When I do 2.5 and I divide by 2, I get 1 25/100. That is my decimal form. That is not my percent form. So I need to take that take that decimal, move it 2 places over to make it a percent form. That's going to be 125%. And then unless they say find the percent of increase or find the percent of decrease, when they just say percent of change, you need to label what that change is, if it's an increase or a decrease. Here, because my numbers are getting bigger as the weekend went on, it's going to be an increase. All right, let's go ahead and take a look at 2 more problems. Find the percent of change, round to the nearest 1/10 of a percent if necessary. All right, 10 inches to 25 inches. All right, we're going to subtract our numbers. 25 comes first. It is the one with the greater absolute value. It's coming first. 25 minus 10, and then we divide by the original. The original number is the first one. 25 minus 10 is 15. 15 divided by 10 gives us 1.5. Then we need to make that into a percent. So when we move that decimal 2 places over, we multiply by 100, we end up getting 150%. And then it's an increase. We started with a smaller number and got bigger. All right, let's take a look at this next one. 57 people to 65 people. 65 is a bigger number. It comes first in our subtraction. 65 minus 57. Divide by the first number. This is our original number. Original number is the one that's going on the bottom. All right, 65 minus 57, that is going to give us 8. Then we're going to take our 8 and we're going to divide by 57. Again, you can use a calculator if you would like to. Okay, so 8 divided by 57 gave me a pretty long decimal, 0.1403 I'm just going to stop there. That's more than enough. 1/10 of a percent. I don't round until after I make it a percent. So 1, 2, decimal will be here. 14 point. And then you look to see what comes next. So here, after my 0, I have a 3 that's less than 5. 5 or more rounds it up, 4 or less rounds it down. So I have 14.0%. This is also an increase. All right, let's try this one. The bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? So we need to subtract our two values. 2012 was 28. 2013 is 20. Okay, those are the two problems that or two numbers we're going to use. Go ahead and pause the video and finish this one on your own. All right, so let's try it. We always put the larger number first, 28 minus 20. And then we divide by what happened first. 2012 came before 2013, so 28 is going on the bottom. 28 minus 20 is 8. Then we're going to do 8 divided by 28. And we get 0.28571. I'm going to stop there. 1, 2 places over. So we have 28 point. And then we're looking at the next number. This was a 5. The number after it is a 7. Since this number is 5 or more, it's going to round that 5 up to a 6, 28.6%. And then it's a decrease here because the number value is going down from one year to the next. All right, percent error. Very similar, but not the same as percent change. So just like percent change, we are going to subtract in our numerator of our problem, as we're setting it up like a fraction or a ratio. We subtract to find the amount of error. We do still subtract the bigger number first, but then we divide by the actual amount. So that is not always the first number in the problem, and most often they actually tell you that number second. So we subtract to find out how much off we were in our guess, and then we divide by the actual amount. Okay, so let's go ahead and try that. You estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. All right, so we're going to do 21 minus 16. And then we divide by the actual. They tell us the actual is 21. That is what's going on the bottom. 21 minus 16 is 5. And now I am going to divide by 21. So you're going to do 5 divided by 21. I get 0.23809. That's enough decimals for me. 1, 2. Looks like that's going to be 23 point, and then the number after the 8 is a 0. That is less than 5, so that 8 is going to stay in 823.8% error. All right. All right, go ahead and pause the video. Try these two on your own. All right, let's go ahead and check our answers. So in example 2, what was the percent of change from 2010 to 2011? Okay, so I have to come back here. 2010 was 18, 2011 was 10. 2010 10 equaled 18, 20, 11 equals 10. Did I write that down right? Yes. Okay, great. All right, so we're going to subtract the numbers in a way that's going to give us a positive answer, 18 minus 10. And then the first number, which is the 2010 one, that's what happened first. That's what goes in our denominator here. We're going to divide by 18. 18 minus 10 is 8, so we are going to do 8 divided by 18. And that gives me 0.4 repeating. I'm going to just write out some 4s here. All right, so to the nearest tenth of a percent, 44.4%, and then that one is going to be a decrease because it is going down from one year to the next. All right, number 4, in example 3, your friend estimates the length of the classroom is 23 feet. Who has the greatest percent error and explain? So let's go ahead and find the percent error. The actual classroom, remember, is 21. So that's still true here. The actual is still 21. Okay, so we're going to subtract 23 minus 21. We're still going to divide by 21. All right. And then we're going to divide. We're going to do 2 divided by 21. We're going to get 0.0952. All right, so I'm going to get 9 point, and then the number after that 5 is a 2. That tells me that the 5 is going to round down. It's going to stay 5. 9.5% error. Okay, let's see. So who's more accurate? Or no, actually the opposite. Who has a greater percent error? Well, my percent error was 23, and my friend's error was 9.5. My percent error is greater because 23 point, what did I say? 8, 23.8. Is greater than 9.5. Okay. Now I could have just looked at the amount of error and explained that way because it didn't specifically say to find the percent error, but I went ahead and found the percent error just for the practice. So my friend was only 2 feet off in his or her guess, but my guess was 5 feet off. So right away I know my guess was farther away. That means I'm going to have a greater percent error. All right, and our last one for today. So to find the percent of change, go ahead and finish this. Write your sentence. Okay, so to find percent of change, hopefully you have something written down. If not, pause the video. Okay, percent of change, we subtract our values. We divide by the original. Okay, and then make a percent. If the number is bigger, it is an increase. the number is smaller, it is a decrease. Okay, so we're actually going to do one more activity together here in our notes, and that is some percent error practice, because really we only did a couple problems together. So on your Google Doc, on your sheet, you're going to record guesses for each one of these categories, and then you're going to calculate your percent error for how close your guess was. So for the shortest adult man, you're going to put how tall you think that person is, and how fast you think the skateboard by a dog is, and the longest fingernails by a female ever. You're going to go ahead and put in some numbers on your worksheet or your Google Doc, depending on which one you're working on, and pause the video, and then you're going to calculate your percent error. So go ahead and pause and write down your guesses. Okay, so go ahead and unpause. Let's take a look at what we have. So for shortest adult man, that's 21.5 inches. So on your sheet, you're going to calculate your percent error. So if you guessed, let's say you guessed 30 inches, then you would subtract 30 inches minus 21.5 and divide by 21.5. So you're going to put whatever your guess is, you're going to subtract 21.5 and divide by your guess, and then that's going to give you your percent error. Okay, fastest 100 meters on a skateboard by a dog. The answer to that one is 19 and 678 thousandths seconds. So go ahead and find your percent error here. Again, you're going to take your answer and subtract it with 19 and 678 seconds. So subtract, get your answer, and then you're going to divide by the actual. And then longest female fingernails ever, 865 centimeters. So you're going to subtract your answer with that number. So let's say you guess 400 centimeters, you do 865 minus your subtraction, your answer, and then divide by the actual 865. All right. And that is it for percent of increase, decrease, and percent error.